So in the last lecture, we used an interface to define the shape of a point object. But there is a problem with this implementation. In object-oriented programming languages, we have this concept called cohesion, which basically means things that are related should be part of one unit. They should go together. This is what we call cohesion. Now back to this example. On the top, we have used an interface to define the shape of a point object. And below that, we have a standalone function. And this is where we have violated the cohesion principle. So the concept of drawing a point is highly related to the structure of a point. It should not be a separate function. Now, if you're going to build a utility library for working with points, chances are you're going to create another function like getDistance that calculates the distance between 2 points. So point A of type point and point B of type point. And this goes to this code block. Again, we have violated the cohesion principle. We have two functions hanging in the air, separate from the point object. Since these concepts are highly related, they should be part of one unit. In object-oriented languages, we call that unit a class. So a class groups properties and functions that are highly related. Now, in this implementation, unfortunately, we cannot move these two functions inside our interface because interfaces are purely for declarations. They cannot include any implementation. In other words, we cannot have the algorithm for calculating the distance between 2 points or drawing a point inside this interface. What we can do instead is to add a function here, a function declaration. So we're going to have a draw function that takes no parameters and returns void, which means it doesn't return anything. Now, you might be asking, why don't we have this point parameter here? Because if all these members, x, y, and draw are part of one unit, we don't need to pass x and y as parameters to the draw function. This function can directly access these properties, x and y, in the same unit. So we don't need this parameter here. Now in interfaces, as I said, we cannot have implementation. We can only have the signature of a function. So with this interface, we're telling TypeScript compiler that our point objects should have two properties, x and y, and a function called draw. The implementation of that is somewhere else. So what should we do now to apply the cohesion principle here? We need to use a class instead of an interface. So on the top, I'm going to change the type to class. And here I'm going to replace this comma with semicolon. So our point class has 3 members. The first 2 members are what we call fields that we use for storing data. And the third member is a function. Now here in this class, we can have the actual implementation of this draw function. So we can simply define it like this: draw, and then add all that logic for drawing a point. Now similarly, we can have another function, getDistance, that returns the distance between this point and another point, like this. Again, all that logic will end up here. Now with this restructuring, you can see that everything about a point is in one unit, in one class. So we have the coordinate, which includes x and y, and 2 functions, draw and getDistance. Now in object-oriented programming terms, we refer to these members as fields and to these functions as methods. So when a function is part of a class, we call it a method. All right, now with this new implementation, we don't want these 2 functions hanging in the air, so delete. This is a much better structure. Also, we're not going to call drawPoint like this anymore. So here's our point class. In the next lecture, I'm going to show you how to create an object of this type and call the draw method.